Okay, so we're going to take a look at installing a soft start on a legacy traditional single stage air conditioning unit. This particular high efficient unit is a 14 SEER. So we're not going to hold that against it. We're going to try to give this a longer life cycle. We're going to decrease the amount of current on startup, and we'll see how efficient this thing runs, and we'll put some gauges on it so we can actually track and monitor its current draw. Okay, let's tear this thing apart and let's get a meter on it and get us a baseline analysis of how we're running before we install the SoftStartHome. Okay, in our kit we're going to find some basic installation instructions, a bunch of connectors. Let's find a good location for it. I'm pretty particular about my installs, and I wasn't able to get it exactly vertical. I had a wiring connector coming through the back plate, so I got it in as good a location as I could, but still provided access to the entire electrical panel. Made sure that there was no refrigerant tubing behind our back panel, so we have a good clean place to attach this thing. The instructions refer you to go to SoftStartHome.com and select your brand so that you get equipment specific wiring, which is really cool. So you want to make sure to go there and check that out so that you get the exact application. And let's bundle things up really nice so we got a good clean install. Now let's fire this puppy up and see what we have as far as a difference. The soft start does give a slight delay to the compressor after the condenser fan motor, and a noticeable change in the tone of the starting of the compressor. Okay, so conclusion, without the soft start, it had a peak inrush of 47.14 amps, and with the soft start, we had a peak inrush of 14.34. That's a pretty significant difference. Definitely would be substantial if we had this on a backup power source, particularly with a generator startup. So, what's the conclusion? Well, the conclusion is, I love new technology, and this is absolutely a new technology, particularly for existing systems. When we look at inverter technology and the way that our industry is moving, we are very much dedicated to conserving electricity in as many ways as possible. All of our new inverters are doing soft start style technology to be able to stage the compressor and our motors in, instead of slamming them on all at once and creating a high inrush of current. So any opportunity that we have to reduce the amount of inrush current on a motor, whether it is a motor moving air or a motor that's moving a vapor pump inside of a compressor, I am all for that. So you can see by our current draw, a very significant drop in the inrush of current, which means I can now use a simple component to be able to change the operation of a piece of equipment, to be able to allow that to be maybe started on a generator, or at least reduce the inrush of current on our electrical grid. And that is really what it's all about. So, do I like the soft start? Yeah, absolutely. Soft start technology is the way to go. And I look forward to seeing the longevity of this piece of equipment to see how it survives over the long haul. I really like the idea that we're not just adding an additional capacitor onto our run capacitor. We're isolating our circuit so that we can now actually control the power coming to our system. If we have an excessive amount of current, we can put it into faults and we can actually shut the unit down. So we're adding some basic diagnostic controls as well. So a wonderful addition to a single stage unit that gives it the ability to be a little bit more sophisticated and efficient.